morning everyone, welcome back to the session on fundamentals of computers, and we were discussing yesterday about operating systems. We'll once revise what were the topics that we were discussing yesterday. We discussed about the definition and the need for operating systems, and then the main functions of an operating system. What are the different functions that we have for an operating system, and the commonly used mechanisms, in which we have just started discussing the process management. What do you mean by process management? Memory management, file management, security, command line interpretation module. I have just given you a gist of about all these modules. Now we'll get into detail for each and every one of them, and then we'll see in today's class about some commonly used OS compatibility enhancement softwares and some popular operating systems. Now we all now know what is an operating system, how is the user able to interact with the computer hardware, what is the role that this operating system is performing. And then we started with process management, right? And we also saw the parameters for measuring system performance. What is the performance of a system when we are measuring it and all. And then we started with process management. What do you mean by process management? First of all, before moving on to process management, we have to first understand what is a process. A process is something called, or a job. We already discussed about it. Process, job, task, whatever it is, all of them have the same function, or you can use these terms interchangeably. But whenever you are using the terminology for an operating system, it's always better to use process or a job. Okay. Now, a process, also called job, is a program in execution. Whatever task or whatever program is being executed, the process of that being happening is known as a process. Okay. Now, process management manages the processes submitted to a system in a manner to minimize idle time of processors. We all know now what a process is. Whenever a task has started or it has been assigned to a program is assigned a task, then that process is known as a job. Okay. Now, in order to manage that task or the process efficiently, we need some management. What kind of management do we need? We need to have a process management that manages the processes submitted to a system in the manner to minimize idle time of processors. Over here you understood process management means managing the processes submitting to a system, but the last part of the sentence describes that in a manner to minimize the idle time of processors. What do you mean by that? It is telling us that it should minimize the idle time of processors. Why is it so important, or why is it the most crucial part of your process management? We all know process management, memory management and all, they are very important tasks for an operating system. They are the core functionalities of your operating system. We all know that. Now, for that, for those functionalities to happen, we are talking about process management. In process management, what is happening? It's saying that it manages all the processes that are submitted to the computer or the system, and in a manner to minimize the idle time of processors. Suppose we have only one processor. Okay. Let's assume a scenario where we only have a process called P1. P1 is the process, or P1 is the process 1 of the processor. We only have one processor, let's assume. You can remove that plural part for a while. Later on, when we talk about multiple processors, then you will use this term, but as of now, just consider to minimize the idle time of a processor. Okay. So, we only have one processor, and in that processor we have three processes. Let's assume. What are the processes? P1, P2, P3 are three processes that are present inside, that are being assigned to this processor. Okay. Now, suppose initially P1 has started early and it went to the CPU and it started doing its process. In between, like I'll show you the diagram and explain. Just a minute, then you'll understand it better. Okay. Fine. Just a minute. This is the diagram that I wanted to show you. Okay. Now, what is happening here? This is the main core part of your processor or CPU, right? Whatever happens inside your system, the operations, everything happens in this control flow itself. So, I was talking to you about a single processor. That single processor was assigned 3 processes, P1, P2, P3. Now, how is it assigned? It is assigned through the control unit into the arithmetic and logical unit. This is your CPU. Over here, your P1, P2, P3 processors are being assigned. From where do you get those processors? Do we have a direct connection between the input or the output unit with the CPU? We don't. So, the only way in which we can assign a process or multiple processes P1, P2, P3 to the CPU is only through your second storage unit. What do you have inside the storage unit? You have the secondary storage and the primary storage. Now, we were talking about minimizing the time for the idle time for a processor, right? We were talking about the minimizing of time for the idle processors. So, we took a processor P, in that we have 3 processes P1, P2, P3, and these processes are assigned from the primary storage into the CPU. Okay, it is being assigned by the primary storage into the CPU. The reason is, from where are you getting the input into the computer? From the input unit. Who is giving the input to the input unit? The user. The program and data which is being given by the user, that is sent as an input. Yesterday we were talking about opening a Microsoft Word file, right? In that we were trying to create a new file or a new document, and we were trying to save that new document that we created. So, let us assume the same example and we will try to understand how many processes are being generated inside that. Okay. So, whenever I double clicked on that Microsoft Word document icon, what will happen? We are sending one instruction, or from the program we are sending an instruction to the input unit that this program needs to load and it has to open the application for us. Now, whenever we are double clicking over there is an input, but the double clicking over here is the input that we are giving to the input unit, and that input unit will send the same thing into the storage unit. In the storage unit, what is happening? Where is your application stored? It is stored in the secondary storage. Now, this storage unit will take care, or it will pick up that particular program that needs to open, and it will send that process, only that single process of the application, to the primary storage. Okay. This primary storage now has one task that needs to be accomplished. The secondary storage duty is only to interact with the primary storage and with the input and output unit, that is it. Okay. Now, this secondary storage, what it does, whenever it got an input, the secondary storage will send the data that is required for that process to the primary storage. Now, the primary storage has a task called, or process called P1. P1 is the process that needs to be completed. Now, when I double clicked on the Microsoft Word document, it sent an input, and the secondary unit it spoke with the primary storage, and a P1 process is waiting here. Let us assume as of now, don't consider the CPU, but we will only consider, just a minute, we will only consider about this part. How is it happening over here? Now, I have sent a process, right? So, P1 is waiting here. When I was opening the Microsoft Word document, I remembered just something and I wanted to open a browser. Now, what I will do, just the same way when I clicked on the Microsoft Word document, the same way I will double click on the browser icon. Whatever the Chrome icon you have, I will be double clicking on that browser icon. Now, what will happen? Again, when we double click, we are giving an input to the input unit. The input unit will in turn go and search in the secondary storage, because on the hard disk itself, right, we are always installing our applications and all the data is being stored on the hard disk. or the secondary storage of your computer or laptop. Now whenever we are double clicking, that input is being sent to the secondary storage, and the secondary storage in turn will talk with the primary storage, and it will say, initially I sent you P1 process for opening a Microsoft Word. Now I have one more process, that is P2, to open a browser also. So the secondary storage will pick up that particular file which needs to open. If you want to open the Chrome file, then there should be one program that should run, right? So it will just pick up that program from the whole Chrome application folder, and it will send it as a process P2 to the primary storage. Now we have P1 that is waiting in the primary storage and P2, right? The same way, I wanted to listen to a music, or I wanted to open the music player on my computer. Immediately what I do first, in the first second, immediately I double clicked on the MS Word document. Then I remembered Chrome. I wanted to open Chrome, so I double clicked on the Chrome. Next I wanted to listen to music, so I will double click on the music player in the computer, that is whatever application you have, you will open it. Now when you are double clicking on each of these applications, the three applications input is sent to the secondary storage, and the secondary storage will pick up the necessary files for opening those applications, and it will send those three files that are required for opening the three documents, MS Word, and then your Chrome, and then your music player. It will send all the three. Now what is happening? The primary storage or your RAM is having three processes that need to be executed. But how many processors do we have? We only have one processor. Just assume a processor is just your CPU. Processor has control unit and an arithmetic and logical unit. Every processor has these two. Now if you have multiple processors, there will be one process here, one process here, one process here, and all of them will be again connected to your RAM itself. There will be only one RAM to which all these processors are connected, and they will interact with one another. Okay. Now in our case we only have one processor, right? That processor is handling three processes for us. So this is our one single process that we have, and this processor is interacting with the primary storage. What do you have in the primary storage? It will tackle all the tasks that need to be completed. Now whenever the user is giving an input or multiple inputs, if he is giving P1, P2, P3, then that input is sent to the secondary storage, and the secondary storage will find out what all programs or what all files are required to open or to process that application. Then what is happening? This secondary storage is sending what all processes need to be executed. They are sent into the primary storage, and in the primary storage now we have P1, P2, P3. You all understood till now, right? Till here you all understood. Now what is the first task that the RAM got? The RAM got opening of a Microsoft document, Word document. Okay, so it is in an order, right? It's all in a sequential order. Now P1 process is first sent to the CPU, as the CPU can only perform one task at a time. So what will this process do? The process is sent to the CPU, only the first process, because it cannot do multiple tasks at a time. Then what will happen? P1 is only sent over here. P2 and P3 have to wait until P1 completes its process. Now P1 is doing its process, that is the Word file opened. Okay, when the Word file opened, the P1 task of opening the Word file is sent to the processor, and it executed that process, and it opened the Word file for us. Now when the open blank Word document is opened, immediately I will go there and click on the option called open an existing file. That is, previously I created some more Word documents, right? I wanted to open them. Then at that point what will happen is, this CPU, which has the process P1 still inside it, doing its operation, it had a task called to open an existing document. At that point what will happen? The CPU will tell the primary storage, wait, P1 still has work to do, you don't send P2 or P3 until P1 is done. Until P1 is done, the control unit manages all this. The control unit will block until P1 completes its task, and it returns the data back to the output unit or to the storage unit. Okay, because okay, now what is happening? P1 is still here. And what is the next instruction that this P1 process got? It got an instruction like it has to open an existing document. Now, where is the existing document in your where is the existing document file located? It's again located in the secondary storage unit. Now, what will this P1 unit do? It will go to the secondary storage unit and it will get the data. Now, what am I doing? Like at this point, we have opened an existing document, okay, and P2 and P3 are still waiting in the processor. At that point, the existing documents need to be changed a little. Now, what will I do? I will make the changes whatever is required. At that point, this CPU has to get the input from the user to make some changes to the Word document. I have to type in something for that existing Word document. Now, this input unit interacts, it talks with this storage unit and it will send the data to the CPU. What is happening at that time? Whenever you are typing, the CPU is idle because it already opened the file for us, a new Word document. Then we said, I want to open an existing file, a function in that. Now, I click on that existing file option, it will ask me for browsing, or it will ask me to choose the file that I want from the secondary storage unit, and I will be able to open the document. Now, once I open the document, existing document, there is nothing that the CPU has to do. It opened the first plain document for us, and then again when we asked to open an existing document, it opened that also for us. At this point, what is happening? The CPU's work is done, it processed everything, but still the processor 1 did not leave this place, or it did not leave the CPU. It is still, we are still making some changes to the input to the Word document through the input. At this point, the CPU is idle, only the input unit is functioning, because whatever we are typing on the keyboard, it is all handled by the input unit. The input unit, it is converting the text, English text that we are typing into the machine language zeros and ones, and it's sending it to the storage unit. How much ever time you are typing, all the time the CPU is idle, right? The CPU has no work and it's just sitting down like that until it has some other task to do. Now, P2 and P3 are the next two processes that we have. What are those two processors, or what are those two processes? The second process, P2, is opening a Chrome tab or Chrome browser, right? Opening a Chrome browser is the second process that we have. And the third process is we wanted to listen to music, so we were trying to open an existing music player application in our system. At this point, P1, which is there in the CPU, it's not allowing P2 or P3 to do its work, and the CPU is also idle. The P1 process, it is not even using the CPU, nor it's neither it's not opening like using the CPU, and it's not even letting P2 or P3 enter into this. The CPU is idle, as well as these processes are not being done. So it is a very big issue and it's a very big problem, right? Whenever we are operating with such things, just imagine with 3 itself, it's taking so much time to process something. Now, in such cases, what will happen? When you just think about multiple processes, like 10-20 applications at a time we'll be using in our computers. In such cases, how will it manage, and how much time should you wait for each and every process to happen one after the other? It will take a lot of time, right? Until we have to wait so much for the P1 process that how much ever the user he'll input the data, it will input and it will send it to the primary storage unit, right? The storage unit in turn will tell the process to save the file. Whenever we complete editing a document, we'll use the save option, right? Whenever you click on the save or you use Ctrl S, what will happen? Again, then there is an input from the keyboard. Ctrl S is are two labeled buttons on your keyboard, right? When you click on Ctrl and S as a combination, it will send a signal from the input unit that there is a process that need to be done, and the storage unit in turn will talk with the control unit, and as it is only for the P1 process which is still inside, the control unit will let that command enter into the CPU, and the processor again saves the document. Once we save that document, the user felt, okay, I am done with this editing, I will close the Microsoft Word. Then he will close the Microsoft Word. When it's closing, it will again send a signal and it will close that document. Once this is done, then P1 will say, okay, my work is done, I will go now, thank you for this, thank you for processing my CPU, thank you for processing my process, okay. Then P1 will go out. Then the control unit will say, okay, P1 left just now, now who is the next one, which is P2. P2 you can enter in and do your work. That is how it happens if you have a single processor here, and also if you are not allowing the other processes, and if you are not able to manage the processors properly. Okay, if you are not able to manage the processors properly, these are the issues we have. The CPU will be idle, and if the CPU is idle, the system is like of no use for us in this kind of a generation. And even in the previous days also, in like 20 years back or 10 years back, it was very difficult for the users to perform operations if the CPU is being idle, and only after one process completely completed, only then we will be able to use one more task or process. It will become so much hectic for anyone to operate such systems. So that is the main concept. Why am I telling you for that one single word so much is, this is the same process, or these examples P1, P2, P3, it will be getting into this CPU. All these things will be used multiple times by us, because we will be understanding what is a uni-programming or uni-processor, then multi-programming, multi-processor, multitasking, multitasking we will understand, multi-threading we have to understand. In each and every one of them, we only have to consider this diagram and different processes P1, P2, P3, how many processors are there in your RAM, and how are they managing all of them, which one is more efficient than the other, and why. This is how we will understand those terms. So this block diagram is very important, as well as the example that I have considered just now is very important. If you didn't like that Microsoft Word, Chrome and music player example, you can just think about any of the applications that you use in your day-to-day life, and you can just think about how is the CPU managing all of them, and how is the operating system helping the CPU to control all of this. Okay. Now, and then we will get back to this slide where we were talking about process management, right. So, processor job is a program and execution. Next, process management manages the processes submitted to a system in a manner to the idle time of processes. The first part you understood previously by the example that I gave you now, you might be able to understand the second part of this statement also. Process management manages the processes submitted to a system in a manner to minimize the idle time of processes. So, what is the idle time here? The CPU. CPU's time. Processor means CPU, right? So, the CPU has some idle time. Why is it getting that idle time? Because of the mismanagement of the processors. Process management is not able to manage properly. In such cases, there will be a lot of idle time for the CPU. In order to reduce all that, we have various algorithms that are present, and very efficient algorithms that help us to switch between tasks. Just because we will be having algorithms where P1 is entering into the CPU, right? Then after a while, it wanted to use the input unit. What is the input unit? It is getting data from the keyboard for that existing file. We are editing that existing file, right? So, in that time the CPU is idle. The process scheduling algorithms or process management algorithms, whatever are there, they will in the meantime when the CPU is idle, it will send the P2 and P3 process into the CPU, and it will efficiently manage them instead of wasting the idle time of processor. Okay. Next, once you understood this concept and once you have an overall idea of what is happening over there, the next thing we have to understand is process management mechanisms. What are these process management mechanisms? Now, I have told you, I just discussed with you one mechanism. That is a mechanism actually which I gave you as an example for your Microsoft Word, Chrome or your music player. That process example is a mechanism that was initially used, and they had so many problems, or in those days that is the best thing that they could do. After that, they slowly evolved and they slowly upgraded themselves, and they wrote efficient algorithms that could perform even better operations with the CPU. So, first we will see what is the initial mechanism that they had. They had manual loading mechanism. What were these mechanisms? Jobs were manually loaded one after another in the computer by the computer operator. When we were discussing about the 5 generations of computers and the computers that were present even before that, before the first generation, what kind of mechanical devices were used, we all discussed about that. And even after we had the first generation of computers, we were using vacuum tubes and we were using so many mechanical gears, shafts to operate the computer in a very large room. So, in such cases we did not have any programming language, or we did not input the data to the computer through any programming languages. It was all through manual entry and through punch cards. That is why I focused so much on punch cards, because in those days, in order to send some instructions or send some input to the computer, the only way they used for input was punch cards. We did not have keyboards in the first generation of computers. Now, what happened then? The manual loading mechanism, what does it mention? Jobs were manually loaded one after the other into the computer by the computer operator. We did not have a program which would automatically send data or execute the tasks one after the other, just like the way we are able to do it in today's world. But there was a computer operator, a manual person or a human being, like the human being, he used to operate the jobs one after the other. He used to input, or he used to send inputs to the computer for one job. Once that job is done, then he used to send, or he or she used to give the input for another task. Once the other task is done, then they will give the input for the third unit. The same way they used to change the jobs one after the other after each process is done. That was the first kind of mechanism for manual loading, that is called manual loading mechanism. And then after that we started with batch processing mechanism. What do you mean by batch processing? Initially there was only one process at a time, right? Even only after the first process done, they were able to do the second process. After that, what they did, how many days will we do like this? Let's club all the similar tasks together and let's operate them at a time. So, in batch processing, what they did was, batch of jobs was submitted together to the computer and job to job transition was done automatically by the operating system. This is related to your second generation of computers. The first manual loading mechanism, you can link it to the first generation of computers, and batch processing mechanism you can link to the second generation of computers. In the second generation of computers, what happened? We clubbed, or we gathered all the tasks, because that was all we could know manually, because the computer operator used to give the input for each and every task, right? So, they used to club different tasks of similar category into one batch, and like that they used to create multiple batches of different group of tasks. Now, what they did, when they used to give the input not only for one task like your manual loading mechanism, but they used to give a set of tasks to the computer at a time. Like if you had 10 tasks, if you can divide them into 4 and 2, then there were 3 batches. First batch had 4 tasks, second batch had 4 tasks, and the third batch had 2 tasks. Now, what they did was, they used to send the first batch with all the 4 tasks at a time into the computer as an input. Whenever they gave that input to the computer, the batch processing mechanism, what it did was, it automatically completed the first task. Once it completed the first task, it automatically shifted to the second task. Once it completed the second task, automatically it shifted to the third task. After that, it completed the 4 tasks and it was left. Now, what they did, after the first batch is done, they used to input the second batch. Now, what is the advantage of batch processing? Initially, they had to put every task into the computer as an input, one after the other. But later, when they clubbed similar task as one batch, they had they minimized the time of giving the data to the task, and also the efficiency increased. With this, there was lesser work that was done by the computer operator, and the computers slowly started automating themselves. Okay. Next, we have job control language, JCL. This is the third mechanism in your process management mechanisms. What does it mean? Control statements were used to facilitate job loading and unloading. Now, there was a language which helped us in controlling the statements, which would facilitate job loading and unloading. Now, initially what we did, first thing, we used to give one task after the other, one task after the other. Then we did batch mechanism. In batch processing mechanism, what happened? We took different tasks, different batches, and we gave input as different set of batches. Now the third thing, job control language, what it did was, it had control statements which were taking care of all the input and output operations or whatever tasks that need to be assigned by the computer itself. We didn't require any other manual operation over here. And then if you see this diagram, you will understand the use of job control statements in batch processing. Okay, what is it doing? How is it controlling? This is one batch, this is one batch, this is one batch, and so how many batches do you have? 1, 2, 3, 4, 5, 6. See, in the sixth batch, how many tasks do you have? 1, 2, 3, 4, 5, 6. This is one batch, right? So they used to send data, or they used to give inputs to the computer in batches, and based on the job and the job that needs to be done by the computer, and based on the instruction it had, the job control statements, these are your job control statements, what all needs to be done. Based on this job control statement, the computer used to understand what needs to be done, and it used to automate things. Okay, and then we have multi-programming. We will see about multi-programming in the next session, but as of now just try to understand these three slides. It is very important and very fundamental for you to understand what is a process, what is process management, and how many kinds of process management mechanisms we had previously. Because if you understand these three slides, then the rest remaining 20 or 30 slides or the next 5-6 concepts which are very important for an operating system, all of them will be very easy for you. So try to focus on this and just understand them. I will once again revise whatever we have discussed today. Generally we have how much process management, which is a process, is a program in execution. We have discussed about a process and process management. What does the process management do? It manages the processes submitted to a system in a manner to minimize the idle time of processors. Whatever idle time that the processors are having, we have to minimize them with the help of process management. Okay, what are the processors? Like CPUs, input output processors, etc. Okay, and then process management mechanisms in the early systems. Whatever process management mechanisms we had previously, they are the loading manual loading mechanism where the computer operator used to shift each and every task, and then we had the batch processing mechanism where a batch of jobs were sent to the computer, and automatically that set of batch tasks were executed by the computer itself. Okay, then we have the job control language JCL, which had job control statements. Based on the job control statements, the batch programming, the batch processing, it used to automate the processes. Okay, and then we'll see the latest or the present processing mechanisms and the programming mechanisms that we are using in the next class. So that's all for today. That's all for this session. We'll meet in this next session. Thank you.